Now coming to logical operators. So logical operators are something which perform some kind of logical operations. So when we say logical operations, if you want to build a bridge of relational expression, like let's say I want to say if a greater than b and a greater than c, how can I bridge these two conditions, a greater than b, a greater than c? That is where this logical operator helps. It can help you to combine multiple relational expressions altogether. So when you use AND, it combines that and checks if both conditions are true, then only the answer will be true. Whereas if you use R, which is two pipe, it will result as true only when one of the condition is true. If all the conditions are false, the result is false. Similarly, if you use logical NOT, it is to reverse the logical value of it. That means if the answer is true, it will give false. If the answer is false, it will give true. Now coming to logical and bitwise operators. Here we are doing just a comparison between what is the difference between ampersand ampersand and ampersand. So ampersand ampersand, if you look at the logical ampersand ampersand looks at the second condition only when the first condition is true, because for ampersand all the condition must be true, then only the result is true. So if at all, let's say first condition itself is false, there's no point in looking at other conditions even all of them are true, because for it every condition must be true. That's why the first condition checking it does, and only when it happens and happens to be true, then only it moves to the second condition. Coming to bitwise ampersand, here in this case if you look at, it checks both it actually converts your number to binary, and it makes the condition value, whatever the value it yields, it will give you that value only when the two bits are 1. Otherwise it will be always 0. So it checks at the bit level whether both the values are true, or you can say 1, then only the answer is 1 or true, or otherwise it is false. Now here is the comparison on how this works. So if you see here, we are combining ampersand ampersand two relational expression. This is one relational expression, this is another relational expression, and the answer of this or this always will be in terms of true or false. You can see here it is false, false, so the answer will always be like that. So if you look at what we are doing here, 10 less than 5 and 10 less than m3, which is 20. So 10 less than 5, is it correct? 10 less than 5 is wrong. So here itself condition is false, so there is no point in checking. So automatically the entire result is false. That is what it shows up here. Similarly, the same thing, 10 less than 5 is false. So there is no need to go to check other condition. That's what we discussed in the previous slide here, this one. So automatically the result will be false. But here if you look at, one difference is it is ampersand, bitwise ampersand. So in the case of bitwise ampersand, if you use, this one will be checked, and once it convert, this one will be checked, and what is the result of it? It is false. Ampersand, this one will be checked, and if the result is true here, false and true, the answer will be false. Here in this case, since anyway it is false, the entire result will be false. Now ternary operator. So ternary operator sometimes is also called as conditional operator. So what does a ternary operator do? Ternary actually means 3. That means any expression which have 3 operators to do its job is called ternary operator. It is more of a, you can call it as a short form of if else, and this is how syntactically it looks like. It has a condition, and where when the condition is true, this part, whatever you have written expression here, will get executed. If it is this condition is false, the expression you have written after colon will be given importance. And here is how we have used a conditional operator. Here we are trying to identify the minimum value. So what we have done is, we have put 200 less than 500. Since 200 less than 500 is correct, so it will give the m value, which is 200. That means minimum is assigned with 200. Let's say if this is false, the n value, which is 500 in this case, gets assigned. But here in this case, 200 less than 500 is true. It has given this m value, which is 200, and assigned to min. So that's why the answer is 200. Now coming to assignment operator, any operator which assigns a value on its right hand side value to its left hand side is called assignment operator. And the basic assignment operator is equal to, apart from that there are other flavors like plus equal to, minus equal to, star equal to, slash equal to, but the basic one is this equal to. So what does this do? So you can see 30 is getting assigned to m1, 40 is getting assigned to m2. After that, using m1 plus equal to 4, which is nothing but m1 equal to m1 plus 4, it is incrementing or updating the m1 value with 4. That means m1 now it is 30, it becomes 34. Similarly, m2, which is 40, you are decrementing by 4, that means m2 becomes 36. And that is value getting printed here.